Assalamualaikum warahmatullahi wabarakatuh. Today I will teach you the what I call the probability distribution function, and yesterday I have taught you how to solve this probability distribution function, and we have discussed a few examples. Discrete.
Welcome to the music world of Ethan. AUX mode.
We have discussed on the discrete probability distribution function. So today we'll continue with discrete probability distribution function. So the properties of a discrete probability distribution function. Now the properties of discrete probability distribution function is given as so one fx or the function fx or the probability function px must greater equal to 0, greater or equal to 0, okay, equal to 0. And number 2, the summation for fx for all x equal to 1. Then we have the, if we have we want to find probability of x element of A, this is equal to summation of x element of A fx. Is the what we call the properties of discrete probability distribution function. Okay. Now we take one example here. So let's say I have example here. Let's say I have example here. I have let's say I have fx is given as fx equal to, let's say fx is equal to x squared over k, and given that x is equal to 1, 2, 3, and 4. So I want to find what's a k value. Find k. By looking at the properties, the properties say that the summation of fx, okay, for all x must equal to 1. Okay, these are second properties. So to find k here, you can use this formula. So the function there is a so we have to find the summation of x squared over k. X is from 1, 2, 3, and 4, and this is equal to 1. So implies that so the first one, 1 square plus k plus by 2 square over k plus by 3 square over k plus by 4 square over k, this must equal to 1. So in other words, this is equal to 1 plus 4 plus 9 plus 16 over k equal to 1. So here you have 20 over k. 20 over k is equal to 1. In other words, k is equal to 20 So this is how we find k. So k here is equal to 20. Okay, this is example number 1. Okay. Now let's say we have one more example here. So example 2, let's say I have here fx is equal to fx equal to the property function is equal to k x plus 1 square. Now x is equal to 2, 3, 4, and 5. Now I want to find k. Find k. This is known as a discrete potential function. So by definition number 2, the properties number 2 say that summation for all k, for all x, fx must be equal to 1. So the discrete potential function is given as, so we have summation of k x plus 1 square for all x, means x is equal to 2, 3, 4, and 5 must equal to 1. So for this case, we have k multiplied by 2 plus 1 square plus by k multiplied by 3 plus 1 square plus k multiplied by 4 plus 1 square plus k multiplied by 5 plus 1 square equal to 1. Okay. So you can solve for this. This is equal to k. So the thing here is 2 plus 3 is equal to 2 plus 1 is equal to 3. 3 squared is 9. 3 plus 9 plus by 16, then plus by 25, plus by 36 equal to 1. So if you solve this one, you will get 9 plus by 16 is 25, 25 plus by 25 is 50, 50 plus by 36 is equal to 86, 86k is equal to 1. In other words, k is equal to, so k is equal to 1 over 86. K is equal to 1 over k is equal to 1 over 86. This, so the new function here, because of k is equal to 1 over 86, the function here is 1 over 86, 86 x plus 1, x plus 1 square. This is how we solve value of k given that the discrete property function. Now, one more example. Let's say I have here, given that, example number 3, given that the discrete property function is given as fx equal to k half power of x. Now x, where x is equal to 1, 2, and 3. 1, 2, and 3. So I want to find the k value here. What is a k value here? What is k value? So by looking at properties number 2, property number 2 to say that summation for all x, fx equal to 1. So this implies summation for x is equal to 1, 2, and 3. So fx is k half power x. This is equal to 1. Okay. So to solve this one, you can write like this: k half to the power of 1 plus by k half to the power of 2 plus by k half to the power of 3. This is equal to 1. So in other words, you can write like this: k half plus by 1 over 4, 1 over 4 plus by 1 over 8 equal to 1. So if you solve this one, we get this equal to, this is equal to, this equal to, so k 1 over 2 is 4 over 8, 4 over 8 plus by 2 over 8 plus by 7 over 8 is equal to 1. So k 4 plus by 2 is, here is 17 over, so 13 over 8, yeah, 13 over 8. So I have here, so it's 13 over 8. So here is 13 over 8 is equal to 1. Or in other words, k is equal to 8 over 13. So our new function here is equal to, our function here is equal to 8 over 8, 8 over 13 half the power of x, because of k is equal to 8 over 13. Okay. Okay, the next lesson I want to show you the joint property function. The joint, the joint, the joint, 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 and discrete probability function. So now for the joint discrete probability function, the properties of a joint discrete probability function say that. So this is for two variables, x and y. The joint probability function means you have two variables. So for the joint discrete probability function, the properties say that the properties of this joint discrete probability function is, so the first one is here A is equal to fx, fxy. The fxy is referred to the joint property discrete probability function is equal to must greater or equal than 0. Okay, must be greater or equal than 0. So must be greater or equal than 0. Okay, this must be greater or equal than 0. Okay. And the second property is the summation for all x and for all y, for all x and for all y, fxy must equal to 1. Equal to 1. So let's say we have one example here. Let's say we have example here. Given that you are given discrete property function. Let's say I have a discrete property function, a joint discrete property function. So the joint property function is given as, let's say, fxy. Joint means you have two variables x and y. So given that fxy is equal to the written as, so you have to write like this: x plus by 3y multiplied by k. So for x in between x from x in between 0, 0 and 4, and y in between 0 and 3, 3 and 0 elsewhere. So I want to find the value of k. So what is the value of k? What is the value of k here? So by referring to the second properties, the second property say that summation for all x and summation for all y, x plus by 3yk, this must equal to 1. So if we solve here, so we solve for y first. We solve for y first inside here. This is the inner part. This is the inner part. Inner part. Inner. Here is the outer part. This is the outer part. Outer part. So we solve the inner part first. So we solve for y first. So y means from 0 to 3 means y is equal to y is 0, 0, 1, 2, and 3. And x is from 0 to 4 means x is equal to x is equal to x is equal to 0, 1, 2, 3, and 4. Okay. So I solved the inner part. Okay. So now, so I want to find so by looking at the second properties. So summation for all x and summation for all y. So the function is x plus by 3y k. Okay. This must equal to 1. So my x here, summation for my x is equal to x is from 0 to 4. So 0, 1, 2, 3, and 4. And y is from 0 to 3, 0, 1, 2, and 3. Okay. The function there is x plus by 3y k. This must equal to 1. So I solve the inner part first. This is the inner part. So the inner part. So I solve for y first. So y is x plus by 3 multiplied by 0 k, then plus by x plus by 3 multiplied by 1 multiplied by k plus by x plus by 3 multiplied by 2 multiplied by k, okay, plus by x plus by 3 multiplied by 3 multiplied by k is equal to 1. And don't forget the outer part. The outer part is summation of x 0, 1, 2, 3, and 4. This is inner part. So we solve the inner part first. So the inner part first here is equal to, so here we have summation of x is equal to 0, 1, 2, 3, and 4. Then here become, So x plus by 3 is x plus by 3. So we can put here k. So we have k. We can solve this one k. X plus by 3. So we have 1, 2, 3, 4x. 1, 2, 3, and 4x. 4x plus by. Okay, plus by. So here is 3 plus by 0 plus by 3 is 3. 3 plus by 6 is equal to 9. 9 plus by 9 is equal to 18. 4x plus by 18. This is equal to 1. Okay. Now then we solve for x. So for x here, so then we solve for x. So we solve for x. So I just continue here. Now I have 4x plus by 18. Okay, so we have here 0, 3 plus by 6, 9. 9 plus by 9 is 18. 4, 1, 2, 3, 4x plus by 18k. So now we have summation for 4x plus by 18k. This is equal to 1. Then you solve for x. X is 0, 1, 2, 3, and 4. So to solve here, you can put here. So k is a constant here, it's coefficient. So just put k there. K. So here is 4 multiplied by 0 plus by 18 plus by 4 multiplied by 1 plus by 18 plus by 4 multiplied by 2 plus by 18 plus by 4 multiplied by 3 plus by 18 plus by 4 multiplied by 4 plus by 18. This is equal to 1. Okay. So I have here 1, 2, 3, 4, 5, 18. So 18 multiplied by 5, so we have 90, isn't it? 18 multiplied by 5 is equal to 90. So 4 multiplied, so we have k, so we have 90 plus by 4 multiplied by 0 is 0 plus by 4 multiplied by 1 is 4 plus by 4 multiplied by 2 is equal to 8 plus by 4 by 3 is 12 plus by 4 by 4 is 16 and this is equal to 1. So I have here, so here this one is 20. 20 plus by 20 is 40. 40 plus by 90 is 130. So 130k is equal to 1, which means k is equal to 1 over 130. So the new function here, so once you, the value of k here is 1 over 130. So when you say the new function here, so you can write your new function is fxy. So your fxy become k is x1 over 130 and 1 over 130. So x plus by 3y because of k is 1 over 1. 0 elsewhere, and x is in between 0 to 4, and y is in between 0 to 3. These are logic function. Okay. Now, let's say I have one more example here. Let's say I have my joint discrete property function. Let's say I have my joint discrete property function is given as, let's say, fxy equal to 2x plus by 5y equal to, so I have here 2x plus by 5y k, for example. Okay, and then x is in between 0 to 3, or x is equal to 0, 1, 2, and 3, while y is equal to 0, 1, and 2, 0 elsewhere. Now I want to find the k value. So by definition, so we refer to definition number 2, summation for all x and summation for all y, okay, fxy, the joint property function, equal to 1. So from here you can get your value of k. So let's say we solve this one. We solve the inner part first. So the inner part is summation of y, and the outer part is summation of x. Okay, so I solve the inner part. So the inner part is summation of y. So summation of y. So we just put like this, summation of x, and then summation of y. The function there is 2x plus by. So we have 2x. So we have 2x plus by 5y k. So the y here equal to 0, 1, and 2, and then this can be written as summation for all x. So I solve the inner part. So for all y, so 2 multiplied by 2 multiplied by x plus by 5 multiplied by 0, then plus by 2 multiplied by x plus by 5 multiplied by 1 plus by 2 multiplied by x plus by 5 multiplied by 2 multiplied by k. This is equal to 1. Okay. So if you solve this one, you will get, so 2x, 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 we have how many x? 2x, we have 6x. So 6x plus by 5 multiplied by 0 is 0. 5 by 5 is 5, is plus by 15. Plus by 15k. Summation of all x. This is equal to 1. So now then to find k, because of this joint distribution property function, joint discrete property function, so to find k, then we need to solve for x. So 6x plus by 15k. So now we have the, just now we have summation of for all x, 6x plus by 15k. Okay, this is equal to 1. And the function for x is now the value for x is from 0 to 0, 1, 2, and 3. So 6x plus by 15k is equal to 1. So to solve this one, you just plug in 0 to 3. So I have here 6 multiplied by 0 plus by 15 plus by 6 multiplied by 1 plus by 15 plus by 6 multiplied by 2 plus by 15 plus by 6 multiplied by 3 plus by 15, then multiplied by k equal to 1. So to solve this one, we have 1, 2, 3, 4, 4, 15. 15 multiplied by 4 is equal to 50 multiplied by 4, we have 60, isn't it? 60. So 50 multiplied by 4 is equal to 64. 30, 45, 60. So 60 plus by 6 multiplied by 0 is 0, plus by 6, plus by 12, plus by 18. So we have here 30 plus by 6, 36. So here is multiplied by k equal to 1. So here is, so 30, 96, k is equal to 1. Or in other words, k is equal to 1 over 96. So k is equal to 1 over 96. You can plug in there the function there, the new function here. So my new function here is fxy. So k is 1 over 96 and 2x plus by 3, 2x plus by 5y for x in between 0 and 3 and y in between 0 and 2. Okay, so don't forget to put 0 elsewhere. This is our function. So this is how to solve the value of k, the value of constant, given that the joint property is your function. Given the joint property is your function. So this is how to solve the problem there. Now the next part, I want to show you a few definitions on the joint property function. Okay. So there is a few concepts here in joint property function. We have the what we call the marginal probability of x. Marginal. So the other part is marginal probability distribution. And for the joint discrete probability distribution function, joint discrete probability function. So the marginal probability of x, okay, the margin of x, the marginal of x, MOX or MOX is written as f sub 1x. F sub 1x is equal to summation for all x fxy. While the marginal probability distribution function of y or MOY is a f sub 2y equal to summation for, sorry, this is summation for all y. Here is summation for all y. This is summation for all y. This is summation for all y. And here is summation for all x, fxy. Okay. Now let's say I have one example here. Let's say I have given that fx plus 3y So let's say I have the joint discrete property function is given as fxy equal to 1 over 130 x plus by 3y 0 elsewhere. So x here is equal to x in between 0 to 4 and y is in between 0 to 0 and 3, 0 elsewhere. 0 elsewhere. Now I want to find the marginal property of function of x, MOX. I want to find MOX or f sub 1x. So f sub 1x by definition is equal to summation for all y fxy. So this can be written as, this is the margin of x, marginal of x. So marginal of x is summation for all y fxy. So this can be written as 1 over 130 summation for all y. So x plus by 3y. So this can be written as, so we sum for all x. Here we have 1 over 130. We sum for all x, for all y. X plus by 3 multiplied by 0. The first y is 0 plus by the second y is 1. X plus by 3 multiplied by 1. And the third y is equal to 2. X plus by 3 multiplied by 2. And the fourth y is equal to 3. X plus by 3 multiplied by 3. Okay. So I have here 3, 9 plus by 6 plus by 9 plus by 9 is 18. So I have 1, 2, 3, 4x. 4x plus by 18 over 130. This is f sub 1x, is the margin of x. Then this must be written properly here. So you can write here like this. You can write, so you can put this way. You can write. So this can be written as f sub 1x equal to. So we have to write here this 1 over 130 4x plus by 18 0 elsewhere. And then here you have to write in terms of the value of x. You have to write in terms of the value of x here. So your x here is equal to x is in between 0 to 4. You don't have to write the range for y because of this marginal of x. Marginal of x, we just focus on x. Okay. Now the second part, let's say I want to find the marginal of y. So I can solve this one. So I want to find the marginal of y. So the marginal of y, so f sub 2y is equal to summation for all x, fxy. So marginal of y, m over y, marginal of y is equal to summation for all x. So summation for all x is given as x is from 0 to 4. Okay. And the function there is 1 over 130 x plus by 3y. So you can bring out 1 over 130. So 1 over 130, we solve this one. X, the first x is 0, 0 plus by 3y, plus by the second x is 1, 1 plus by 3y. And we have the third one is 2, 2 plus by 3y. The fourth one is 3, 3 plus by 3y. And the fifth one is 4, 4 plus by 3y. So I have 1, 2, 3, 4, 5y, 15y. So here it comes 1 over 130, 15y plus by, here I have 1, 3, 6, and 10. So 15y plus by 10. So in proper way, the proper way of writing this one, you can write like this. So this is equal to the property function fxy here. So the the joint property function of x of y, f sub to y, f sub to y. So f f sub to y is equal to, so this can be written as f sub to y is equal to, so here is 1 over 30, 1 over 130, 10 plus by 15y, or 15 plus by 15y plus by 10, or 10 plus 50y. So 0 elsewhere, and then this value is, you have to focus, you have to you have to focus on the uh, the value of y. So because of here is margin of y. So y here in between, y in between y in between 3 and 0. So these are how we write the property function of the marginal property function of y. Now, then the other part is, the other topic is on the joint property function. And there's a conditional property function. Now, the conditional property function. The conditional probability function for discrete random variable. For discrete property function. For a discrete, for a discrete, for a discrete, for a discrete property. For discrete, for discrete property function. Okay, now conditional property for discrete property function. So property of x given y, property of x given y, this can be written as, is a property of x intersect y over probability of y. Now, in terms of condition probability involving two variables here, so this can be written as a, this can be written as a, or you can put here as a fxy. The same concept apply. Fxy is fx y, the conditional, the joint probability function, divided by the the marginal of y, f sub to y. Okay, the same thing here. So if you have property of y given x, by definition is equal to property of x intersect y divided by property of x. And in terms of function here, property function we can write this f, the condition of y given x is equal to f, the condition of y given x is equal to fxy divided by the property of y given for the conditional is f sub 1x. This is how we solve the conditional function. Okay, look at one example here. Now, let's say I have, example here, I have fxy is given as 3x plus y over 130, or 130 3x plus by y, okay, like this. So then x is from 0 to 4 and y is from 0 to 3 and 0 as well. Now I want to find the fx given y. Fx given y. Then I also want to find fy given x. So by definition, fx given y is, so fx given y, fx given y is equal to fx given y is equal to fxy divided by f sub to y. Then this one, fy given x is, this thing is equal to fyx or fxy. So fxy, fxy. So I have here fxy divided by f sub 1 x. Okay. So to solve this one, let's for example we solve this one. So I want to find fxy. So to solve this one, we need to find f to y, and this one we need to find f sub 1 x, f sub 2 y and f sub 1 x. So first of all, we need to find f sub 1 x and f sub 2 y. So previously we have found the f. Okay. Now let's say try to find the f sub 1 x and f sub 2 y. Okay. So just find new one. So I want to find, so because of the formula they involved, so fxy, I want to find fx given y. So this is equal to fxy divided by f sub to y. So f sub to y, we know that fxy, okay, fxy is equal to, this is equal to fxy is 130, 1 over 130 multiplied by 3x plus by y, 3x plus by y, divided by f sub to y. So f sub to y, we have to find f sub to y. F sub to y equal to summation for all x fxy. So if you solve this one, you get fxy is 1 over 130. We have 1 over 130. So summation for all x. So 3x plus by y. So if you solve this one, so where x is from, x is in between x here, the x here is in between 0 to 4, x here in between 0 to 4. So if you solve here, you get 1 over 130. Okay, so I have here 3x, 3 multiplied by 0 is 3 multiplied by 0 plus by y plus by 3 multiplied by 1. We do the same example, the same process like we do before. So if you don't want to do this one, you can just pick up the example before. So 3 plus by 3 multiplied by 1 plus by y, and plus by 3 multiplied by 2 plus by y plus by 3 multiplied by 3 multiplied by 3 plus by y, then plus by 3 multiplied by 4 plus by y. These are marginal of y. So I have 1, 2, 3, 4, 5y here. So 1 over 130 5y. plus by, so here you have 3 multiplied by 3 multiplied by 1, 3, 1, 3 plus by 6 is 9, 9 plus by 9, 18, 18 plus by 12 is equal to 30. So I have here 1, 2, 3, 4. So here is 3, 3 plus by 3 plus by 6 is equal to 9. 9 plus by 9 is equal to 18. 18 plus by 12 is equal to 30. So 5y plus by 30. So I have here plus 5y plus by 30. So this can be written as, so here can be written as, so here this can be written as 1 over 130 3x plus y over, so f sub to y is equal to 1 over 130 multiplied by 5y plus by 30. So the thing here, you can cancel out this one and this one. So I have here 3x plus by y over 5y plus by 30. This is the final answer for f, the combination of fx given y. Okay. So the final answer here is 3x plus y over 5y over 30. Okay. So so fx given y is equal to 3x plus y over 5y plus by 30. So 0 as well. So because of this thing involve condition of x, so the function here you have to put here as a x. So here you have to put you have to put you have to write here the range of x only. So x in between x in between 0 and 4. Now, let's say I want to find the last one. I want to find the combination of y given x. So I want to find, let's say I want to find f y given x. So f y given x is equal to, I want to find f y given x. So f y given x is equal to f x y divided by f sub 1x. So this is equal to fxy. We know that fxy is the positive function just now is 3x plus y. So here is 3x plus y over 100. Or I can put this way. So here is 1 over 130 3x plus by y over f sub 1x. Now the problem here is we need to find, then the range here is for y. So y here is in between 0 to 0 to 3. 0 to 3. And here is 0 elsewhere. So the thing here, we need to find f sub 1x. So f sub 1x. F sub 1x can be written as um, f sub 1x, f sub 1x is equal to f, f sub 1x equal to summation for all y fxy. So this is equal to summation for y is between 0 to 3. So the function there is 1 over 130 3x plus by y. 3x plus by y. So if you sum for all y here, you get, so here is 1 over 130. So the y here, so we just focus on y. So nothing to do with x plus by 0 plus by 3x plus by 1 plus by 3x plus by 2 plus by 3x plus by 3, because of the last y is 3. So here is equal to 1 over 130. So I have 1, 2, 3, 4. 4 multiplied by 3 is 12x plus by 6 over 130. So the final answer here is fx given y. Okay, fx given y. Sorry, just now is fx fy given fy given x. So the fy, the condition y given x is equal to fxy divided by f sub 1x. So this can be written as 130 over 130. This can be written as 1 over 130 multiplied by 3x plus by y over 1 over 130 multiplied by 12x plus by 6. So y is in between 0 and 3 and 0 elsewhere. This is how you write the probability function of y, the conditional of y given x. So this can be cancelled off, this can be cancelled off. Okay? So you have 3x plus by y over 12x plus by 6. This is how we write the conditional probability of y given x, and previously we have learned the probability of s given y. Now let's say I want to find what is the value for, let's say I have here, I want to find, the other part is I want to find what is the value for probability of y equal to 3 given x equal to 2, for example. So y equal to 3, x given 2. So this one, you can refer to this part. So this you can refer to probability of y given x. They just plug in y as 2 and s as a 3 here into this function, you will get. So this one is equal to 3 multiplied by 3 multiplied by 2 plus by 3 over 12 multiplied by 2 plus by 6. So the final answer here is equal to 3, 3 to 6, 6, 9, 9 over 24 plus by 6 is equal to 39 over 30. So this is how we solve the function here. Okay. Okay. I want you to solve. Let's say I have a few examples here. Exercise here. I want you to solve this one. Exercise. Exercise. I have exercise here. So, so let's say I have one given that. So I have here. Okay, I have here exercise here. Let's say I have number one. I have the property function, the discrete property function is given as is given as a fx equal to 2 over q. Okay, thanks. Where x is equal to 1, 2, 3, and 4. And b, I have here fx equal to q x plus by 1 over 3 x is equal to 1, 2, 3, and 4. And C, I have here fx is equal to q 1 over x squared. X is equal to 1, 2, and 3. So you need to find q. Find q. Okay, this is our first question. Okay, then I have for the joint of the function here, I have, let's say I have here given that number 2, the joint of the joint discrete of the function is given as so fxy equal to x squared plus by 2y over x squared plus 2y multiplied by k, okay, x in between 0 and 3 and y in between 0 and 3. 0 as well. Okay. So find k and b probability of x greater or equal than 2. This in terms of value. Okay? This in terms of value. What is the value here? Okay? And then C, I want you to find probability of x is equal to 2 and y is greater or equal than 1. This is question number 2. Then question number 3 is a third question. Question number 3. Given that the joint probability function, the joint discrete probability function is given as okay, fxy equal to, so I have here x plus by 2y over 3m. 0 as well, and x in between 0 and 3, and y is in between 0 and also 0 and 3. I want you to find a value of m, b probability of x, you have to find the probability of x equal to 2 given y is equal to 1. Then C, probability of y is equal to 1 given x is equal to 2. Then D, I want you to find the, okay, that's all. I want to find, this one. That's all right. So I have a 3 question here. Try to solve this one. And this you don't have to don't have to submit to me, just for your exercise. Please solve this one, and maybe we can discuss the answer here during our webinar. Right? So you can solve this one, and we can discuss during the webinar. I think that's all for today. So until next week. So please try to solve question number 1, 2, and 3, and do it yourself. You don't have to send to me. These are just for your exercise. Okay, then we'll meet next week through the webinar. Assalamualaikum warahmatullahi